Hello, and welcome to my lab report for Physics 2211 at the Georgia Institute of Technology. This report will recap Lab 2, projectile motion. This lab was all about projectile motion. The lab group observed the motion of a known object, determined the net force acting on said object, and lastly, compared real life to simulations using the Tracker app and GlowScript simulation software. Some relevant formulas were how to calculate the gravitational force acting on an object, as well as the force of drag. Ultimately, the lab group found that the simulation software is inherently limited when only the gravitational force is accounted for, something that will be discussed later on. To do this lab as we did it, you'll need a small, lightweight object to throw. Think along the lines of something like a balled up piece of paper. You'll also need a meter stick to measure the distance. Lastly, you'll need some sort of recording device to upload a video into the tracker software on the computer before using the starter code created by Dr. Munoz to create a simulation in GlowScript. Once everything was measured, recorded, and uploaded, it was time to compare the real-life conditions with the simulated ideals in GlowScript. Interestingly, the trajectories of the simulation with just gravity and the simulation with gravity and drag are near identical. This is likely because the drag force was so small that there was minimal force opposing the motion of the object, meaning that the velocity of the object in the x direction didn't change that much. Also important to note is that the arc of the tracker data, this blue one down below, the two lines, uh, is very similar to the arc of the trajectory with gravity and drag. This indicates that the real world drag force was likely really small, so that we also saw with the GlowScript software. This does mean that simulations can be somewhat useful in predicting the motion of a projectile. However, anyone trying to predict the motion should be diligent to calculate and factor in all variables accurately. If the object were thrown straight up, the trajectory would firstly be very different. There would likely be very little movement from left to right on the x-axis of the graph, as the object would be unlikely to move significantly in those directions. Secondly, the trajectory graph would likely be closer to a true parabola, where points are kind of mirrored across a vertical line of symmetry, as compared to this simulation, where we're starting at the origin of movement, and then we're only moving down to the right. Lastly, the object's velocity, acceleration, and net force vectors would also all change as the object would be moving up, down, and in the x direction instead of just moving down in the x direction. That concludes my lab report. Thank you.